guys, welcome to your YouTube channel where we talk all about the GATE exam and we are into the quick revision mode. Just now we understood the process state transition diagram in the previous video, so we are going to solve the GATE question based upon it. So here is the very first question. The GATE 2020, it was asked in, let me just read out the question. Consider the following statements about process state transition for a system using the preemptive scheduling. So we have the preemptive scheduling system. The scheduling algorithms applied are preemptive, right? And preemptive will be applied only when it is going to be a multi-program system. So there is no point that it can be a uni-program system. Alright? Just keep in your mind the process state transition diagram just that we understood in the previous video. A running process can move to ready state. Preemptive scheduling. So you have the ready state and you have the running state. In the preemptive scheduling it goes like this, correct? And from here we go the block state like this and we go back like this. Simple. That will make up your everything clear. So a running process can move to ready state. Yes, very much on preemption it moves to the ready state. A ready process can move to the running state. Yes, when it is dispatched it moves to the running state. So this statement is also true. A blocked process can move to the running state. A blocked process can move to the running state. You see here a blocked process. Does it move to the running state? No, not at all. A block process, if at all the input output is done or the event is done, will always move to where? It will move to the ready state and will get dispatched again as per the scheduling algorithm, but will not directly go to the running state. So that statement number 3 is wrong. Let's check for the fourth. A blocked process can move to the ready state. Exactly. What else it will do? It will move to the ready state. Okay. So out of the 4, first is true, second is true, fourth is true. Which of the above statements are true? Which combination is correct? First, second and fourth are true. That's option number D. Answer is option D because the statement number 3 is a false statement. As simple as that. Alright, the next question is from the GATE 2005. Quite a simple question. It is quite dependent on one term, that is swap space, which I mentioned in the previous video that when we suspend a process from ready state to the suspend state, the medium term scheduler suspends the process and put into the swap space which is available on the secondary memory. So it is all about that. Let's read the question. What is the swap space in the disk used for? Quite a direct question, but somebody who doesn't know swap space might get confused. So the options are option A, saving temporary HTML pages. No. Saving process data. Yes. Storing the super block, definitely no. Storing the device drivers, absolutely no. Right? We have seen that in the secondary storage, the swap space which is created is used to temporarily store, it's for storing the process and its data which are temporarily suspended from the ready state or the ready queue. So the answer is quite straight, nothing to be worried about here. Option B, saving the process data, this has been used. Alright, so the next question is right here on the board, asked in the GATE 2009. Quite a lengthy question, but as simple as other questions were. So let me read out the question for you. In the following process state transition diagram, so this is the process state transition diagram for a uniprocessor system, assume that there are always some processes in the ready state. So in your ready state, you always have some process, okay? So it's quite showing the multi-programming system. So this is a STD given, start to ready, ready to running, then terminated, then coming to the block state and then coming to the ready state. A simple state transition diagram that we have seen so many times. Now it is given 4 statements and it is going to ask which of the given statements are true. First statement is if a process makes a transition D, that means this is happening. So if a process is getting terminated, it would result in another process taking transition A immediately. That means a new process will be created and put into the ready state immediately. Is it necessary? I don't think so. A process is getting terminated, then why a new process has to get created and put into the ready state immediately? No, there is no such need. We already have many processes. It's not a uniprogram system. It's a multi-program system. So we already have processes in here to get scheduled on the running state. In fact, I can say that if a process is getting terminated, what is necessary immediately is that a transition B happens, not a transition A happens. If somebody is going off from CPU, to make its utilization continuous, the CPU scheduler has to put a process, should pick a process and put it into the running state. That means transition B should happen if D is happening, but not A. Okay, so this certainly seems to be false. Okay, next statement. Number 2, a process P1 in blocked state, so a P1 is there in the block state, can make transition E, so it is making the transition E, that means going back to the ready state, blocking is over, while another process P2 is in running state. So we have a process P2 in the running state. Is it possible? So a process P1 in the block state can make transition E while another P2 is in running state. Yes. What is a harm? There is no problem. A process can be blocked, a process can be running. Different, right? And the block process, even if it is coming to the ready state, the process P2 can be still running. They have no correlation. Correct? So this statement is true. Yes, this is possible. Quite possible. Now, number 3, the operating system uses preemptive scheduling. Very much visible. A process here from the ready running state, we are making a transition C, which is coming to the ready state, which simply shows, this edge shows what? This edge shows preemption. A preemptive scheduling algorithm applied, a priority process went in and a non-priority process came back. So that's why this edge is there, which shows the preemptive scheduling. So yes, it is preemptive scheduling. Now the 4th one is the operating system uses non-preemptive scheduling. Quite false, because the 3rd one is true. Right? First statement is false, second is true, true and false. Now the question asks which of the given statements are true. Okay, so here are the combinations in terms of option. So we found second and third to be true, second and third to be true. So answer becomes what? Answer becomes option C, that the second and the third are true. I hope the questions are quite clear and understood, and the process STD is very much revised on all terms by now. If at all any doubt, please put them down in the comment section. If you want any particular question which is troubling you, just put it down. Maybe you can go for the discussion, or I can come up with a solution. I will see you very soon once again with the context switch and the CPU scheduling algorithms. Till then, bye-bye.